Hi, today is June 13, and today I will be talking about my summary for the research paper, a multi-channel CNN-LSTM network for daily activity recognition using smartwatch sensor data. So the purpose of this research paper is to identify human activities, and this can be used in many different areas, such as health monitoring, elderly care, sports, security systems, military, etc. The data comes from an already created public data set. Um, oh, Data set where two participants wear a smartwatch on their hand and perform some activities. So the data is collected from the accelerometer on the smartwatch at a sampling rate of 10 hertz. So in this research paper, the researchers used an LSTM model, a CNN model, and a multi-channel hybrid CNN-LSTM. So this multi-channel CNN LSTM model was trained with 3, 5, 10, 30, and 60-second windows of data points with tenfold cross-validation to see like which window was yielded the best performance. The baseline CNN and LSTM models were also trained with tenfold cross-validation. So for the results, the experiment found that at a window size of 10 seconds, the CNN LSTM hybrid model achieved the highest accuracy of 94.55%. And this model outperformed the basic CNN and LSTM models. Additionally, a third experiment was conducted where the multi-channel CNN LSTM model was trained with position data as well as accelerometer data with window sizes of 10 seconds. This new model achieved the highest accuracy of 96.87%. So there are several innovations in this paper. The biggest is that in this paper, unique multi-channeled hybrid model was created, and this model, and the unique thing was that it had three channels from the accelerometer XYZ dimension data, data to separately conduct convolutions on the data from the three different axes. And it also included both convolutional layers and LSTM layers. And this multi-channel CNN LSTM model was found to outperform the traditional baseline models. So overall, I did find two challenges or unclear details. The first challenge I found was that the data set is pretty small. There are only two participants generating the activity data, so there is not a healthy variation of activity data. And many people might do the same action differently than the two participants who generated the data. For example, many people might cook differently or have wider steps when they're walking or wash dishes in a different way. And the model may face difficulties in classifying the actions of other people in real life. So, in other words, I feel this model is a bit undergeneralized. And a second, not really a challenge, but an unclear detail about this paper was that it is unclear how the baseline models take in data. Um, the research paper did not mention how the baseline or basic CNN and basic LSTM models um, process or take in the signals. It is unclear whether, for example, the CNN takes in the signals as a picture or like isolates each dimension of the accelerometer signals at, for 1D convolution. And it is unclear whether or not the data is segmented into windows and how long each window is. And I feel like this might pose a little problem in the research paper because different ways for taking in data will affect the performance of the baseline models. And then that just poses a question to the credibility of whether or not the multi-channel CNN or LSTM will outperform the baseline models in different scenarios. And so that's my review and summary of this research paper for today. Thank you, and yeah.